Good evening, my dear students. Now, today in this video clip, I want to discuss about sharpness of resonance and quality factor. Now, in the previous video clip, already you know about that is said to be resonance, that is said to be electrical resonance and resonant frequency. That resonant frequency is represented by omega naught or is said to be F naught. What is F naught? That is F naught is equal to 1 upon 2 pi under root of LC. What about omega naught? Omega naught is 1 by root of LC. Already we discussed about this expression and also derived these two expressions. Now, when you draw the current along, draw the graph current along that is the y-axis and frequency along x-axis, it shows the variation of the current with a variation of the frequency. And at low frequency, the current flow through the LCR circuit is minimum. At high frequency, the current flow through the LCR circuit is minimum. But at one particular frequency, the maximum current flow through that series LCR circuit. That shows is said to be maximum current. At that time, that is said to be electrical resonance. At that time, that is Z is equal to what you say R. Impedance is minimum. And then R is equal to Z. At that time, XL is equal to what you say XC. And inductive reactance is equal to capacitive reactance in the series LCR circuit. Now it shows this one. Now observe this expression. The resonant frequency mainly depending upon the self-inductance and the capacitance of the capacitor. Self-inductance of the inductor and the capacitance of the capacitor. But it is independent of the R. It is independent of R. And in this series LCR circuit, the dependent quantity, what is the dependent quantity of the resistance R? That is said to be sharpness. Sharpness ಏನಿದೆ ಅಲ್ಲ ಅದು ಏನು ಮಾಡ್ತದೆ sharpness of the resistance ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ನಾನು ಇಲ್ಲಿ ಡ್ರಾ ಮಾಡಿದ್ದೀನಿ ನಾನು ಇಲ್ಲಿ ಹಾಫ್ ಪವರ್ ಪಾಯಿಂಟ್ಸ್ ಇದೆ ಇದ್ರಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪವರ್ ಇದೆ. Now this is the current for half power points anta. This current is said to be for the half power current this one. Half power current ಅಂದ್ರೆ ಏನು? ನಾನು ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್ ಬರ್ತೀನಿ. ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇದರೊಳಗೆ ಇಲ್ಲಿ sharpness ಅದ. Sharpness means what? Sharpness of the resonance. On either side of the resonant frequency, in what rate the current is decreases. And slowly it is decreases or rapidly it decreases. That shows that is said to be sharpness. Now in this graph, now say for the resistance R1 in the circuit, this is the more sharpness. This is the less resistance. Less resistance, more sharpness. More sharpness is nothing but what? Now it is rate of decrease in the current in this case. That is the maximum here. ಅಂದ್ರೆ ಇಲ್ಲಿ rate of decrease of current ಹೆಚ್ಚಿದೆ ಇದರಲ್ಲಿ. But rate of decrease of current that is said to be according to for the comparison of the for resistance R3 and for resistance R2. Now this is a less value. Again it is more less value. It means less sharpness. Suddenly decrease of the current ಅಂದ್ರೆ more sharpness. Slowly decrease of less sharpness. Less sharpness. ಅದಕ್ಕಿಂತ ಹೆಚ್ಚು. This is more sharp. It shows the sharpness. How the rate of current is decreased on either side of the, that is said to be resonant frequency. That shows the sharpness of the resonance. How it the decrease from maximum current to go on decreases on either side of the frequency. In what rate it is decreased? How it is decreased? That shows the sharpness of the resonance. And you come to the quality factor. That depending upon there is the quality factor. It means the more quality factor, there is a more sharpness. ಇದು ಕ್ವಾಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ ಹೆಚ್ಚಿರುತ್ತೆ, ಇದು ಕಡಿಮೆ ಇರುತ್ತೆ, ಇದಕ್ಕಿನ್ನೂ ಕಡಿಮೆ ಇರುತ್ತೆ. ಕ್ವಾಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ ಇಕ್ವೇಶನ್ ನೆಕ್ಸ್ಟ್ ಕೊಡೋಣ ನಾವು. ಇಕ್ವೇಶನ್ ಆಫ್ ಕ್ವಾಲಿಟಿ ಫ್ಯಾಕ್ಟರ್ ಇವಾಗ we got the equation of the quality factor and what is the bandwidth. Now this is the maximum current Imax. At that time maximum power is Imax square R. At this point The maximum power is I max square R. Now half power point. This is point. At this point, power is half of the maximum power. Now here I is the current for half power. Half of the maximum power. Now I max. Now for this current, what is this current? I is the current for half of the maximum power. I max is maximum current. Half of the power. Now what is the power at this point for this current? That is the P is equal to I square R. E point power is I square R is. Then from equation number 1, equation number 2, equation number 3. Now from this expression, from P is equal to I square R. I square R. Now the maximum power is I max square R divided by 2. What you got the expression for the current at the half power in terms of maximum power. I square R get cancels. I square is equal to I max square divided by 2. I will get I max upon root 2. Illustrate current. Illustrate I max by root 2. This is the current for half of the maximum power in the series LCR circuit. Now, from this point and this point, the cutoff frequency. This is the cutoff frequency. These two frequencies are called half power points of the frequencies. Half power point frequencies. Half of the maximum power. Now omega 1, omega 2 are the frequencies at the half power of the maximum power. This is point. Now difference of these two, omega 2 to omega 0, omega 1, delta omega. Now omega 1 is omega 0 minus delta omega. Omega 0 minus delta omega. Omega 2, omega 0 plus delta omega. Omega 0 plus delta omega. Now difference of these two, omega 2 minus omega 1, 2 delta omega. How you got omega 2 minus omega 1, omega 0 plus delta omega, omega 0 plus delta omega, minus of omega 0, minus become plus delta omega. Now omega 2 minus omega 1, delta omega plus delta omega. Now omega 2 minus omega 1, 2 delta omega. Difference in the frequencies of the at the half of the maximum power points in the series LCR circuit. This is called bandwidth. This is called bandwidth. Bandwidth means what? It is the difference in the frequencies at the half of the maximum power in the series LCR circuit. This is called bandwidth. This omega 2 minus omega 1 is 2 delta omega. Now you come to the definition of the quality factor. Quality factor you defined in 3 ways. There are 3 important definitions. Whatever you define that definition, that is all the 3 definitions give the same meaning. Now see here, quality factor is defined as the ratio of the resonant frequency to the bandwidth. Omega 0 divided by 2 delta omega. 2 delta omega is the bandwidth. It is the ratio of the resonant frequency to the bandwidth is called quality factor. Now quality factor is equal to omega 0 divided by omega 2 minus omega 1 is equal to omega 0 divided by delta omega. Already you know omega 2 and omega 1 are the frequencies at the half of the maximum power points. Okay. Now Q is equal to F0 divided by F2 minus F1. Now F or omega ತಗೊಂಡ್ರೆ F ತಗೊಂಡಿದ್ರೆ F2 minus F1. This is one definition. Now in quality factor it is a unitless. This is the unitless. This is said to be unitless quantity. Now quality factor is also defined as the inductive reactance at the resonant frequency to the resistance. It is the ratio of the inductive reactance at the resonance to the resistance. This is the second definition. Third definition, the quality factor is also defined as the capacitive reactance at the resonance to the resistance in the series LCR circuit. It is also defined like Xc divided by R. This is the capacitive reactance at the resonance omega 0. Take omega 0 C divided by R. Now Q is equal to 1 upon omega 0 C R. Whatever it may be, quality factor is inversely proportional to bandwidth. It is inversely proportional to bandwidth. There are three definitions. Quality factor is defined as the ratio of the resonant frequency to the bandwidth. Second definition, it is the ratio of the inductive reactance at the resonance to the resistance. And third one is the quality factor is defined as the ratio of the capacitive reactance at the resonance to the resistance. Now in this case, you observe this expression and also you observe this expression. In this expression, quality factor is inversely proportional to the resistance. Means more resistance, less quality factor. For what resistance is more resistance? R1 is more resistance. R1 is more resistance. Less quality factor. More quality factor. Again more quality factor. More quality factor, more sharpness. More sharpness of the resonance shows how the rate of current is decreases on either side of the resonant frequency. This is about very important point, that is about the sharpness of the resonance and the quality factor. You define the quality factor in 3 ways. Okay, thank you. Good evening, dear students. Now in AC circuit, what is the power? What is the power factor? Especially that is in a series LCR circuit. ನಾವು ತೋಳ್ತಾ ಇರೋದು ಇಲ್ಲಿ ಸೀರೀಸ್ LCR ಸರ್ಕ್ಯೂಟ್. ಅದು ಹೇಳಿದೆ ನಾನು ಇದಕ್ಕಿಂತ ಬಿಗಿನಿಂಗ್ ಕ್ಲಾಸ್ ಏನು, ವಾಟ್ ಎವರ್ ಯು ಅಪ್ಲೈ ದ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ವೋಲ್ಟೇಜ್ across the series LCR circuit, it compulsory at the low frequency. ಅಪ್ಲೈ ಮಾಡೋದು ಯಾವ ಫ್ರೀಕ್ವೆನ್ಸಿ? at low frequency. at low frequency ಅಂದ್ರೆ XC greater than XL ಇರುತ್ತೆ. ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್ ತಗೊಂಡು ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಇಲ್ಲೇ ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, ಇಕ್ವೇಶನ್ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ. ವಾಟ್ ಇಸ್ ದ ಪವರ್ ಫ್ಯಾಕ್ಟರ್? ಸಿ ನೋ at the low frequency XC is greater than XL, what are the expression for the voltage and the current? That I have to see this first. Now applied voltage V equal to V0 sin omega t. Okay, now I is equal to I0 sin omega t plus pi. ನಾ ಹೇಳಿದೆ ನಾನು ಅಕಸ್ಮಾತ್ ಹೈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆದ್ರೆ ಇದು ಮೈನಸ್ ಪೈ ಬರುತ್ತೆ, ಲೋ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಪ್ಲಸ್ ಪೈ ಬರುತ್ತೆ, ಹೈ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಮೈನಸ್ ಪೈ ಬರುತ್ತೆ. ಹಾಗಾದ್ರೆ ರೆಸೋನೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿಗೆ ಏನ್ ಬರುತ್ತೆ? ಇದು 0 ಬರುತ್ತೆ. ಅಂದ್ರೆ ಇದು 0 ಅಂದ್ರೆ ಪ್ಯೂರ್ ರೆಸಿಸ್ಟಿವ್ ಸರ್ಕ್ಯೂಟ್ ಏನ್ ಬರುತ್ತಾ ಅದು ಬರುತ್ತಾ. ಸರಿ, ಇಂಪಿಡೆನ್ಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ Z is equal to under root of R square plus XC minus XL whole square. ನಾ ಹೇಳಿದ್ನಲ್ಲ ಲೋ ಫ್ರೀಕ್ವೆನ್ಸಿ. Now what is the instantaneous power? Now this is the instantaneous voltage in series LCR circuit, or you said to be EMF. Now it is the instantaneous current in the series LCR circuit. Now instantaneous power, that is product of voltage and the current. It is a product of voltage and current. P is equal to P into I. P0 sin omega t, I0 sin omega t plus y. Okay. Now P0 sin omega t, P0 into I0 sin omega t, ಉಳಿದದ್ದು sin omega t plus pi. ಹಾಗಿದ್ರೆ sin omega t plus pi ಅಂದ್ರೆ sin a plus b ತಗೊಳ್ತಾವಲ್ಲ ಆ ತರ, sin a cos b cos a sin b ಆ ತರ. Yes, what do you got this expression? sin omega t cos pi plus cos omega t sin pi. Got like this. Now multiply this one. P0 into P is equal to V0 into I0 sin omega t sin square omega t cos pi plus P0 into I0 sin omega t cos omega t sin pi. Equation number 3. Now work done over the one cycle of AC, what do you got? Now see here, this is power into time. Power into time, now expression for the power is equal to rate of doing work done divided by time, work done is equal to power into time. ಈಗ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಟೋಟಲ್ ಪವರ್ ಬೇಕಿತ್ತಂದ್ರೆ ಇಂಟಗ್ರೇಷನ್ ಮಾಡಬೇಕು. P into dt, power into time, under the integration over under the limit 0 to t. Now what is the P? P0 I0 sin square omega t cos pi plus P0 I0 sin omega t cos omega t sin pi. Whatever you take here, at that point dt. The exponential w is equal to p naught I naught cos pi ನಾವು ಹೊರಗಡೆ ತಗೊಂಡೆ ಉಳಿದಿದ್ದು ಇಂಟಗ್ರೇಷನ್ ಓವರ್ sin square omega t dt under the limit 0 to t. Now you will know the p naught into I naught sin omega t cos omega t ಇದನ್ನ ಇಂಟಗ್ರೇಷನ್ ಮಾಡೋದು, ಇದನ್ನ ಹೊರಗಡೆ ತಗೊಂಡು ಯಾಕಂದ್ರೆ ಟೈಮ್ ಇದೆ. ಓಕೆ, p naught I naught sin pi ಇದನ್ನ ತಗೊಂಡೆ ಇಂಟಗ್ರೇಷನ್ ಹೊರಗಡೆ, ಇಂಟಗ್ರೇಷನ್ ಓವರ್ sin omega t cos omega t dt equation number 4. ಈಗ ಈ ಡೈರೆಕ್ಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನಿಮಗೆ ಅರ್ಥ ಆಗಬೇಕು ಅಂದ್ರೆ ಇದಕ್ಕಿಂತ ಮೊದಲು ಹೇಳಿರ್ತಕ್ಕಂಥ ಡಿಸ್ಕಸ್ ಮಾಡಿರ್ತಕ್ಕಂಥ ಎಲ್ಲಾ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡ್ಬೇಕು. ಏನು ಅಲ್ಲಿ ಇಂಟಗ್ರೇಷನ್ ಓವರ್ sin square omega t dt ಅಂಡರ್ ದ ಲಿಮಿಟ್ 0 to t ಏನ್ ಬರುತ್ತೆ t/2 ಬರುತ್ತೆ. ಇದು ಆಲ್ರೆಡಿ ಹೇಳಿದ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡ್ರಿ. ಅಂಡ್ ಇಂಟಗ್ರೇಷನ್ ಓವರ್ sin omega t into cos omega t dt integral sin omega t into cos omega t sin 2 omega t divided by 2 to dt this equal to 0. Now once again I repeat, this point integration of this one and integration of this point already in the beginning classes, beginning video clips. Now equation 4 becomes equation 4 ಬರೋಣ. ಈಗ ಏನ್ ಮಾಡೋದು ಇವಾಗ ಇಂಟಗ್ರೇಷನ್ sin square omega t dt t/2 ತಗೊಂಡ್ಬಿಡೋದು ಇದನ್ನ p naught into I naught cos pi into t/2. Okay, now integration of sin omega t into cos omega t dt ಏನಾಯ್ತು 0 ಬಂತು. Now this term becomes 0, total term becomes 0, this term becomes 0. At that time only you got p naught I naught cos pi, ಇದರ ಬೆಲೆ t/2, you take t/2. ಇದು ನಾನೇನ್ ಮಾಡ್ತೇನೆ 2 ಇದಕ್ಕೆ ಇದಕ್ಕೊಂದಿಷ್ಟು ರೂಟ್ 2 ಇದು ರೂಟ್ 2 ಮಾಡ್ತೀನಿ, ರೂಟ್ 2 into ರೂಟ್ 2 again 2. Now p naught divided by root 2 I naught divided by root 2 cos pi into t. Okay, now p naught by root 2 this is the root mean square value. ಮತ್ತೆ ವಿಡಿಯೋ ಕ್ಲಿಪ್ ನೋಡಬೇಕು, ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್. p naught by root 2 I naught by root 2 vrms I rms. Okay, into cos pi divided by t ಇದು ಬರುತ್ತೆ. ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನ್ ಬರ್ತಿಲ್ಲ, w is equal to prms into irms, okay, into cos pi into t ಬರುತ್ತೆ. ಯಾವುದು w, but average power, what you got the average power work done divided by time, total time taken for 1 cycle of AC. Average power for 1 cycle of AC, total 1 cycle ಗೆ ಅವಾಗೇನಂತೆ average power prms into irms cos pi into t whole divided by t. ಇಲ್ಲೇನಾಯ್ತು ಟಿ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ಉಳಿದಿರೋದು prms into irms into cos pi ಉಳಿತು. ಹಾ, ಇಲ್ಲಿ ಬರೋಣ. ಪಿ ಅವರೇಜ್ ಇದಕ್ಕೆ ನಾವು ಟ್ರೂ ಪವರ್ ಅಂತ ನೋಡಿ, ಅವರೇಜ್ ಪವರ್ ಏನಂತೇವೆ ಟ್ರೂ ಪವರ್ ಅಂತೀವಿ. ಇಲ್ಲೆಲ್ಲ ನೋಡಿದ್ರು ಇದಿಷ್ಟಕ್ಕೆ, ಇದಕ್ಕೆ ನಾವೇನಂತೀವಿ ವರ್ಚುವಲ್ ಪವರ್ ಅಂತ. ದಿಸ್ ಇಸ್ ಯೂಸ್ಡ್ ಟು ಬಿ ವರ್ಚುವಲ್ ಪವರ್. Now equation 5 becomes what we want to see here. Average power, this is the actual power. Prms into irms is virtual power. This is actual power. P average, this is the virtual power into cos pi. Now cos pi is equal to actual power divided by virtual power, equation number 6. It is the expression for what you say, that is a power factor. ಇದಕ್ಕೆ ನಾವೇನಂತೀವಿ power factor ಅಂತ. Now power factor is defined as the ratio of the actual power to the virtual power in the series LCR circuit. It is defined as the ratio of the actual power to the virtual power in the AC circuit. This is about power in AC circuit and you said to be power factor. Then you take the impedance diagram. Impedance diagram, this is R, I think it is O, this is A, this is B, this is the impedance diagram, this is the impedance, this is the resistance, this is XC minus XL. What you got? Cos pi is equal to R by Z. Now Z is under root of R square plus X, R square plus XC minus XL whole square. Therefore R by Z is R divided by under root of R square plus XC minus XL whole square. Yes, okay, fine. Now tan pi no ಇಲ್ಲಿ ಬರುತ್ತೆ. XC minus XL divided by R ಅಂತ ಬರ್ತದೆ. This is the expression for, that is the phase angle ಅಂತಾನು ನಾವೇನ್ ಮಾಡಬಹುದು ಇಲ್ಲಿ ತಗೊಳ್ಳಿಕ್ಕೆ ಬರುತ್ತಾ. ಇದು ಇಕ್ವೇಶನ್ ತಗೊಂಡು ಬೇರೆ ಬೇರೆ ಸರ್ಕ್ಯೂಟ್ಗೆ ನಾವೇನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತಾ, ಡಿಸ್ಕಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತಾ. ಈಗ ಎಲ್ ಇಲ್ಲಪ್ಪ, ಅವಾಗ ನಾವು ಬರೀ ಎಕ್ಸಿ ತಗೋತೇವೆ. ಸಿ ಇಲ್ಲ, ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಎಕ್ಸೆಲ್ ತಗೋತೇವೆ. ಆರ್ ಇಲ್ಲ, ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಎಕ್ಸಿ ಅಂಡ್ ಎಕ್ಸೆಲ್ ತಗೊಂಡು ಹೇಳ್ತೇವೆ. ಯಾವ್ದನ್ನ ಅಬ್ಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಈಗ ಆರ್ ಎಲ್ ಇದ್ರೆ ಆರ್ ಎಲ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ, ಎಲ್ ಸಿ ಇದ್ರೆ ಎಲ್ ಸಿ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ, ಆರ್ ಸಿ ಇದ್ರೆ ಆರ್ ಸಿ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ, 3 ಇದ್ರೆ ಸೀರೀಸ್ ಎಲ್ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ. ಅದಕ್ಕೆ ನಾವು ಬೇರೆ ಬೇರೆ ಸರ್ಕ್ಯೂಟ್ಗೆ ಏನ್ ಮಾಡ್ಬೋದು, ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು. ಇದ ಪಾಯಿಂಟ್ ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ತಗೊಂಡು ಈ ಟ್ಯಾನ್ ಪೈ, ಈ ಪೈ ಹೀಗೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತಾ, ಹೀಗೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತಾ. ಸಮ್ ಟೈಮ್ ಪಿ ಸಿ ಮೈನಸ್ ಪಿ ಎಲ್ ಡಿವೈಡ್ ಬೈ ಆರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತಾ. ವೋಲ್ಟೇಜ್ ಅಕ್ರಾಸ್ ದಿಸ್ ಒನ್ ಡಿವೈಡ್ ಬೈ ಇದು ಪಿ ಆರ್ ಆಗುತ್ತೆ. ಮತ್ತೆ ಇದು ವಿ ಸಿ ಮೈನಸ್ ವಿ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಪಿ ಆರ್ ತಗೋಬೇಕಾ. ಈ ತರ ನಾವೇನ್ ಮಾಡಬಹುದು, ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಕಂಡುಹಿಡಿಯಬಹುದು. ದಿಸ್ ಇಸ್ ಅಬೌಟ್ discussion about the power factor. Once again I repeat, whatever you study that series LCR circuit, it is always, in this case always, you apply the voltage at what? Low frequency. This is a very very important concept in this discussion. Okay, thank you. Good morning my dear students. Now today in this video clip I want to explain about the power factor and the LC oscillations. But already you know that is the power factor. Power factor, it is particularly in the series LCR circuit. It is in the series LCR circuit. Okay. Now what is called the expression power factor? How you define this one? Now you obtain the expression for the power factor in the previous video clip. It is defined as the ratio of the actual power to the virtual power. Actual power means V into I. That is the instantaneous value of voltage, instantaneous value of current. Virtual power is V RMS into I RMS. This is one definition. Another definition is the power factor is also defined as, that is the ratio of the resistance to the impedance of the circuit. That is in the LCR circuit, resistance or impedance is under root of R square plus XC minus XL whole square. Capacitive reactance XC, XL is inductive reactance. Fine, okay. Now this power factor is depending upon the R and L and C. Inductive reactance, self-inductance and capacitance, and inductive capacitive reactance and inductive reactance. Once again, depending upon also that is the frequency. Istu factor may depend on that. Depending upon R, depending upon L, depends upon C, and also that is the frequency. Istu factor may depend. Now that is the help of this is the impedance diagram. Tan pi is equal to XC minus XL divided by R. Now the phase angle between the voltage and current in series LCR circuit, tan inverse of XC minus XL divided by R. Now this pi is mainly depending upon that is the frequency in the series LCR circuit. Now discuss this one about this expression you have to take here. In a pure resistive circuit, what happens? P in phase with I. P in phase with I, phase difference is 0. Phase difference is 0. Power factor cos pi cos 0 is 1. Power factor is 1. Power factor is 1 for the pure resistive circuit. This is point. This is first point. Second point. Now the pure inductor coil. For the pure inductor coil, what happens? I lags V by pi is equal to pi by 2. Perfect, it is said to be 90 degree. If it is 90 degree, power factor is equal to 0. Power factor for pure inductor coil is equal to 0. For pure resistive circuit, cos pi is equal to 1. ಯಾಕಂದ್ರೆ ಪರ್ಫೆಕ್ಟ್ ಇನ್ ಫೇಸ್ ಇರುತ್ತೆ 100% ನಾವು ಜೀರೋ ಅಂತ ಹೇಳ್ಬೋದು ಎಲ್ಲಿ ಪ್ಯೂರ್ ರೆಸಿಸ್ಟಿವ್ ಸರ್ಕ್ಯೂಟ್. ಇನ್ ಪ್ಯೂರ್ ಇಂಡಕ್ಟಿವ್ ಸರ್ಕ್ಯೂಟ್ ಒಳಗ 100% ದ ಪೈ ಏನದ 90 ಡಿಗ್ರಿ ಇರುತ್ತೆ. ನಾ ಹೇಳಕತ್ತಿರೋದು ಪ್ಯೂರ್ ಇಂಡಕ್ಟಿವ್ ಸರ್ಕ್ಯೂಟ್. ಥರ್ಡ್ ಒನ್ ಪ್ಯೂರ್ ಕೆಪಾಸಿಟಿವ್ ಸರ್ಕ್ಯೂಟ್. ಕೆಪಾಸಿಟರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ I leads P by pi is equal to pi by 2 is equal to 90 degree. Again it is power factor is equal to what you say 0. Why? Because cos 90 is 0, cos pi is equal to 0. Okay. Now in the fourth point, in the series LCR circuit, other than that is resonant frequency, at that time pi is any angle ಏನಾದ್ರೂ ಇರ್ಬೋದು, ಪಿ ಲೀಡ್ಸ್ ಐ ಇರ್ಬೋದು, ಐ ಲೀಡ್ಸ್ ಪಿ ಇರ್ಬೋದು. ಅವಾಗ ಪೈ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗ್ತಿರ್ತದ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಎಕ್ಸ್ ಸಿ ಮೈನಸ್ ಎಕ್ಸ್ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಆಗುತ್ತೆ. ಏನಾದ್ರೂ ಬರ್ಬೋದು. ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಎನಿ ದಿಸ್ ಒನ್ ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಎಷ್ಟಾದ್ರೂ ಬರ್ಬೋದು. ಎನಿ ನೋ ದಿಸ್ ಒನ್ ಇಟ್ ಇಸ್ ಎ ಲೈ ಬಿಟ್ವೀನ್ 0 to 1 ಏನ್ ಬರ್ಬೋದು. ನಾ ಹೇಳಕತ್ತಿರೋದು ಸೀರೀಸ್ LCR ಸರ್ಕ್ಯೂಟ್ ನೊಳಗ ಫಾರ್ ಎನಿ ಫ್ರೀಕ್ವೆನ್ಸಿ. ನೋ ಫಿಫ್ತ್ ಒನ್ ಇನ್ ಸೀರೀಸ್ LCR ಸರ್ಕ್ಯೂಟ್, that is series LCR circuit at resonant frequency. What happens at resonant frequency? P in phase with I or perfect ಏನಾಗಿರ್ತದೆ pi is equal to 0 ಬರುತ್ತೆ. At the resonant frequency it is acts like a pure resistive circuit. At that time power factor is equal to 1. Now see, in these two cases, that is power factor is 0, means there is no loss of power in the pure inductive and pure capacitive circuit. Therefore the current flow through the pure capacitive circuit or pure inductive circuit, that current is called wattless current. Actually power factor 0, there is no dissipation of power and alternating current flow through the what you say in the pure inductor and pure capacitive circuit. At that time that current is said to be wattless current. ಇದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ wattless current. ಬಟ್ ಡಿಫೈನ್ wattless current ಅಂದ್ರೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಈ ತರ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಥ್ಯಾಂಕ್ ಯು. ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ವಾಟ್ ಯು ಸೇ that is power factor and wattless current definition. Thank you.